Dentists and their staff who operate radiographic equipment are occupationally exposed to radiation. This includes potential exposure from the primary beam and scattered radiation. In this video, I will describe the methods to minimize dose to the operator and discuss the regulatory limitations on radiation dose to occupationally exposed individuals. As an operator, you can reduce your dose by using shielding or by using position and distance. You can monitor your dose on a periodic basis to ensure that your practices for dose reduction are effective and to document that your doses are within the limits. Dentists should consult with a qualified expert, typically a medical physicist, who will help in the design of the radiological shielding. This shielding will consider the location of your X-ray units and also proximity of staff who may not be occupationally exposed to ionizing radiation. For example, the front desk staff. Note that the barriers are designed with a leaded window so that you can maintain visual contact with the patient during the exposure. In the absence of a barrier, you can use distance to minimize the intensity of the radiation that reaches you. This principle is based on the inverse square law. That is, the intensity of radiation is inversely proportional to the square of the distance from the source. In this example, an air kerma of 200 milligray is measured at a distance of 1 foot from the source. Increasing that distance to 6 feet decreases the radiation 5.56 milligray and underscores the dramatic reduction in radiation intensity that is achievable with distance. In addition to distance, position yourself at an angle of 90 to 135 degrees to the primary beam of radiation. This position represents the location where the least amount of scattered radiation reaches the operator. The use of handheld portable X-ray units requires special considerations. These devices are battery operated and are held by the operator during exposure. A lead shield at the end of the device blocks radiation that is scattered back to the operator. However, it is important to note that for the shield to be effective, the operator must be trained and you should hold and position the device appropriately. The use of handheld devices will be the topic of a subsequent lecture. To ensure that you and your staff consistently follow radiation safety precautions, you can monitor radiation dose using these radiation dosimeters. The two dosimeters depicted here monitor full body dosage. These monitoring devices are typically clipped onto the clothing on the front of the chest. The OSLD dosimeter, or optically stimulated luminescent dosimeter, is provided by a service and is typically returned on a monthly basis for dose monitoring. Other technologies such as the InstaDose dosimeter have a USB interface that allows you to directly read the dose. So who needs to wear a dosimeter? The NCRP recommends that if your anticipated exposure is more than 1 millisievert, you should wear a dosimeter. Also, occupationally exposed individuals who are pregnant should wear a dosimeter to document the dose during the period of pregnancy. California state regulations are slightly different. You are required to wear a personal dosimeter if your anticipated exposure is more than 10% of the maximum allowable dose. That is, if your anticipated exposure is more than 5 millisieverts per year. And employees who declare pregnancy should also be provided with a dosimeter. So what are the limits for ionizing radiation exposure for occupationally exposed individuals? In the United States, that limit is 50 millisieverts per year for occupational exposure. Furthermore, pregnant radiation workers have additional limitations, and the dose to the embryo and fetus should not exceed 0.5 millisieverts per month. Dentomaxillofacial imaging is a low-dose procedure, and thus occupational exposure can also be anticipated to be lower. Indeed, studies have demonstrated that occupational exposure of dentists and their staff is well below 1 millisieverts, and thus typically dental offices do not use personal dose monitoring. With this information, you should now be able to safely use X-rays for diagnostic imaging.